Hello everyone, welcome back again to Embedded System course. So we are doing practical sessions. So in a previous session we studied practical number 1, and in this session we are going to study practical number 2. Okay, so the title of this practical number 2 is Development and Execution of Program in C for Arithmetic Operation and Time Delay. Okay, so there are two parts. First is performing arithmetic operations that we can do by using arithmetic operators uh, available in a C, and we will also study how to generate a time delay. Okay, so that is by using for loop. Okay, so that we will study writing time delay function. So for this we are going to study three programs. First program is uh, its statement is LEDs are connected to bits or pins of port 1 and port 2. Okay, write a 8051C program to show the content 00H to FFH on LEDs after 100 milliseconds continuously. ओके, सो व्हॉट इथं काय करायचं आहे, पोर्ट 1 आणि पोर्ट 2 ला आपल्याला काउंट 00 टू FF आउट करायचं आहे. ओके, and after outputting a particular count on port 1 and port 2, uh, we have to generate 100 millisecond delay, and this should happen continuously. This is the first program. Second program is write a 8051C program to toggle. Okay, 2 is missing here. To toggle all the bits of port 0, port 1 and port 2 with 250 millisecond delay. Okay, now here specially it is asked to use SFR keyword to declare port addresses. Okay, and program number 3, again here is a typographic mistake. This is program number 3. A door sensor is connected to pin number 1 of port 1. Okay, so that door, its analogous form is a switch. Okay, if switch is open, door is open. If switch is closed, door is closed. So such a door sensor is connected to pin number 1 of port 1, and a buzzer is connected to pin number 7 of port 1. Okay, so we have to write a C program to monitor the door sensor, and when it is open, okay, then sound the buzzer by sending a square wave of few hertz. Okay, so this is third program. Okay, so now we will proceed towards, so I have already written these programs in a 3 program files. Okay, we will study one by one. I will open the project file for that. Okay, so this is project 2 file that is created for this practical number 2. Okay, so this is title of practical number 2, development and execution of program in C for arithmetic operation and time delay. This is program number 1. LEDs are connected to bits of port 1 and port 2. Write a C program to show the counts 00H to FFH on LEDs after 100 millisecond continuously. So for that program is written. See the program. Okay, so here as usual, that is hash include reg51.h, then uh, SFR. Okay, SFR LED is equal to 0x80. Okay, so I'm declaring LED as a SFR type of variable, means I'm representing uh, SFR of 8051 microcontroller. Okay, by using symbol or name LED. Okay, and I'm assigning address 0x80, which is address of actually port 2. Okay, means actually I am declaring LED as SFR type of variable, okay, which is representing port 2. Okay, then this is a function declaration of ms delay function. Okay, so void ms delay, and to this function I am passing unsigned int type of variable. Okay, so this is function declaration. Okay, before because in this main function we are calling this ms delay function, and uh, ms delay function's definition is coming after this main function. Okay, so before its definition occurs we are using this function, so it is necessary to declare this function here. Okay, void ms delay unsigned int z. This is function declaration of function name ms delay. Okay, then main function void main void. See inside void main void what we are doing. So inside void main void, p1 is equal to 0 means port 1. In port 1 we are loading data 00h, so that will configure port 1 as output. LED, in LED SFR type of variable I am loading 00h. Okay, LED is equal to 0 means we are loading 00h into LED. But what is LED? LED is nothing but actually we are representing port 2 by using name LED. Okay, so I am configuring port 1 and port 2 as output ports here. Okay, by using these two statements. Then while 1, while when 1 means what? It is infinite while loop. Okay, so whatever enclosed in between opening and closing braces here, three statements are there, that will be repeated continuously, infinitely. Okay, and what is going to be repeated infinitely? So these three statements. First statement is p1 plus plus, where plus plus is increment operator, that is arithmetic operation. So this statement is equivalent to p1 is equal to p1 plus 1. Okay, so this p1 plus plus is nothing but p1 is equal to p1 plus 1, means whatever content in p1 we are incrementing it by 1. Okay, similarly LED plus plus means what? LED is equal to LED plus 1, and LED is what? It is nothing but port 2. We are representing port 2 by using symbol LED. So here by using these two statements, what we are doing? We are incrementing content of port 1 and port 2. Okay, so previously initially content of port 1 and port 2 are 00. Okay, so we are incrementing it by 1, and then we are calling ms delay function. To this function we are passing 100 value, means it will generate 100 millisecond delay. How? For that ms delay function is written. Okay, assuming that f oscillator frequency is 11.0592 megahertz. Okay, then this ms delay function, okay, will generate uh, delay in millisecond of a value we are passing to this function. Right now we are passing what value? 100. So 100 will get assigned to z. Okay, in this function. Okay, and see here inside this function ms delay function, what is written? So there are two loops, for loops. This for loop is inside this outer for loop. Okay, so this uh, for loop, okay, so internal for loop contain no looping statements. Okay, so it will just execute this. First it will check this condition, and if it is true it will increment this z. Okay, so first for loop is for I is equal to 0, I is less than z, where z we have passed 100, that will get assigned to z. Okay, means this outer loop will get executed for 100 times. Okay, so 100 times, and then uh, when this condition is true, what will happen? I is less than z, I is initialized with 0. Okay, initially z is 100, I is 0, so this condition will be true and control will go to the internal for loop. So this for loop is for j is equal to 0, j is less than 1275, and j plus plus. Okay, so this loop will initialize j with 0, and unless and until j becomes 1275, this loop will be repeated. Means this inner loop will be repeated how many number of times? 1275. Okay, in this way this inner loop will be repeated how many times? Z times, means 100 times. Means this total for loop will be repeated for how many times? This inner internal or inner for loop, that is 100 multiplied by 1275, and that will generate 100 millisecond delay. Okay, so we are incrementing content of port 1 and port 2, and we are calling delay of 100 millisecond. Okay, now I will compile or build this program by pressing this icon. Okay, so there are no errors, zero errors. Okay, now I can proceed for execution or uh, running this program. So start debug session. Okay, so I am going to monitor what? I am going to monitor this port 1 and port 2. which are already opened. Okay, data in port 1 and port 2 right now are FF. Okay, now I will perform initially execution stepwise. For that I will press on this step or press F11 key. Okay, so P1 is equal to 0, LED is equal to 0, that will configure port 1 and port 2 as output ports. Now control goes inside this while loop. See here. Okay, P1 will be incremented by 1. Okay, so now P1 becomes 1. Okay, then P2 will get incremented by 1. So from FF it will get incremented by 1. Okay, so it will become so it will get incremented from 0 because we have loaded 0 here in P1 and LED. I will again start this. So here P1 will be initialized with 0, P2 will be initialized 0, and then inside P1 and P2 will get incremented to 0 1, from 0 0 to 0 1. Okay, and then delay. So to see the output, I will now run the program. See. Okay, so after every 100 millisecond, count in port 1 and port 2 will get incremented by 1, and these values changes from 00H to FFH. In this way the program executes. Program is incrementing or counting up from 00 to FF, port 1 and port 2 data, that is the data on port 1 and port 2 pins. Okay, so in this way it is continuously uh, counting up with 100 millisecond delay in between. Okay, so this is program number 1. I will stop debug session. Okay, so I will close this. Okay, now I will remove this program and I will add the second program which I have already written in second file. Okay, add existing files. So practical 2, so program 2, add, close. So I have added here. This is program 2. Okay, from practical number 2. So what is this program? Write a C program uh, to toggle all the bits of port 0, port 1 and port 2 with 250 millisecond delay. Use SFR keyword to declare port addresses. Okay, so see here, uh, here include reg51.h, and next I am here, it is specifically asked that use SFR keyword to declare port addresses. Okay, so that means here SFR port 0 is equal to 0x80. Okay, so here 0x80 is the address of port 0, so that I am assigning to SFR type of variable port 0, means I am representing port 0 by using symbol or variable name port 0. Similarly, next statement is SFR port 1 is equal to 0x90, where 0x90 is the address of port 1, means I am representing or I am assigning address of port 1 to symbol or variable port 1 of type SFR, means I am representing port 1 by using symbol port 1. Okay, similarly port SFR port 2 is equal to 0xA0, where 0xA0 is the address of port 2 that I am assigning to symbol port 2. Okay, that means I am representing port 2 by using symbol port 2 in the following program. Void ms delay unsigned int z, this is function declaration of ms delay function. Okay, next is main program. Now see the main program. So we have to toggle data on port 0 and port 0 1 2 continuously with delay of 250 millisecond in between. So for that, see here, port 0, okay, port 0 is equal to 0x55. I am assigning value 0x55, means what? That is 0 1 0 1 0 1 0 1. Okay, so this is 55. Okay, so I'm assigning 55 to port 0, port 1 and port 2. Okay, and then I am calling a 250 millisecond delay. Okay, for that I am calling this function ms delay and passing 250 to that function, means this function will generate delay of 250 millisecond, assuming that f oscillator frequency connected to the microcontroller is of 11.0592 megahertz. Okay, next part is Now I have to toggle this data. Okay, so if I toggle this data 0101, so what I will get? I will get 1010. Okay, 1010, which is in hex is nothing but AAH. Okay, so this is in hex is nothing but 55H. Okay, so I'm toggling this data now in port 0, port 1 and port 2. So for that I'm loading AA 0xA into port 0, port 1 and port 2. Okay, then again I'm calling ms delay of that is function, and to that function I'm passing value 250, that will generate 250 millisecond delay. Okay, so in this way these statements which are in inside while loop, and while loop, in this while loop condition for continuation of loop is 1, means it will be always 1, means true, means this is infinite while loop. Infinite while loop means what? Continuously whatever statements are there are in loop, okay, that will be continuously executing. Okay, so in this way what we are doing, after each 250 millisecond we are toggling data in port 0, port 1 and port 2. Okay, for that we are loading 55 into port 0, port 1, port 2, then calling delay of 250 millisecond, then we are loading A into port 0, port 1, port 2, and we are calling 250 millisecond, and this is happening continuously. Okay, in this way the data in port 0, port 1 and port 2 are continuously toggling, and that is achieved here, that is been asked in the program. Okay, so this part we have already discussed, that is ms delay function, that is same ms delay function we are using to generate delay. Okay, now we will build this program, check for errors. So there are no errors. Okay, now we will debug this program. We will go in debug session. Okay, so port 1, port 2 already open, we have to just open port 0. Okay, so this is port 0, this is port 1, and this is port 2. Okay, now I will first do step execution. See, so here control is here inside this while loop. Okay, so port 0 first we are outputting 55, port 0 data is 55, then port 1 data is 55, port 2 data is 55. So first 55 is uh, outputted on port 0, port 1, port 2, then ms delay, I will come out here, then it will go to next statement, then I am outputting. Now I am toggling means now this is 0, this is 1, this is 0, this is 1, this is 0, this is 1, this is 0, this is 1. Now I am toggling means I am making this 1, this 0, this 1, this 0, this 1, this 0, this 1, this 0 in all the ports, port 0, port 1, port 2. See, okay, so first is toggle, second is toggle, and third is toggle. Okay, okay, this is also toggle. Okay, now I will run this program so that that will be visible to you. See, the data in port 0, port 1 and port 2 is continuously toggling. Okay, and what is delay in between? That is of 250 millisecond, that is 0.25 seconds. Okay, in this way we can do this. Okay, so this is program number 2. Okay, I will stop debug session. Now we will proceed to the last program, program number 3. Okay, so for that program file I have already created, so I will just remove this program 2 file and I will add that program 3 file. Program 3 file, add, close. Program 3 file. So what is this program? A door sensor is connected to pin number 1 of port 1, and a buzzer is connected to uh, pin number 7 of port 1. Okay, then write a C program to monitor the sensor. Okay, and when it is open, sound the buzzer. okay, by sending a square wave of few hertz. Okay, so this is the program. A door sensor is connected to pin number of pin number 1 of port 1. Okay, and a buzzer is connected to pin number 7 of port 1. Okay, write a C program to monitor the door sensor and when it is open. Okay, so when sensor is open means door is open, sound the buzzer by sending a square wave of few hertz. Okay, so for that program is written here. So hash include reg51. I am representing pin number 1 of port 1 to which a door sensor is connected by using symbol D sensor. For that this statement is written as bit D sensor is equal to P1 caret 1. Okay, so this statement will assign address of pin number 1 of port 1 to D sensor symbol or variable of S bit type. Similarly, I am representing pin number 7 of port 1 by using symbol or variable of S bit type, that is buzzer. So that in my program I can use, instead of using this P1 caret 1 and P1 caret 7, I can now use D sensor and buzzer so that readability of your program will improve. Okay, next is MS delay function declaration as usual. Then main program void main void and see D sensor is equal to 1. First statement is D sensor is equal to 1 semi-comma. This will configure, that is D sensor means it is representing pin number 1 of port 1. So that pin will be configured as input because the sensor is connected to that pin. Okay. Similarly, buzzer is equal to 0 semi-comma. This will configure pin number 7 of port 1. That is buzzer is representing actually pin number 7 of port 1. So that I am configuring as output because buzzer is connected to that pin. Okay, so that buzzer will turn on when I supply a square wave on that pin number 7 of port 1. If I generate square wave of few hertz on pin number 7 of port 1, that buzzer will turn on. It will generate sound. Okay, now main program. While 1 means continuously, what we are going to do, we have to monitor sensor. Okay, and if that sensor is open means door is open. Okay, so when door is open, suppose that sensor is a switch. If switch is open, okay, switch is connected between pin number 7 of port 1, that is D sensor, and ground. So when door is open, that switch is open, we can assume switch is open, and when switch is open, then input at the pin 7 of port 1 is 1. Okay, means if door is open, we have to generate sound on buzzer. Okay, that for that, if I'm using if statement, if D sensor is equal to 1 means door is open, then I have to generate sound on buzzer. How? For that I have to generate a square wave on pin number 7 of port 1, that is buzzer pin. Okay, of few hertz. For that the program is written here. So I'm making buzzer 1, that pin number 7 of port 1 I'm making 1, and then I'm calling delay of 200 microsecond, and then I'm making buzzer 0. Okay, and again we are calling ms delay of 200 millisecond. So it is generating square wave of 400 millisecond time period. Okay, so once this is executed, okay, so it will generate one square wave. Okay, and if this door sensor is not equal to 1, then what will happen? It will not generate such square wave on pin number 7 of port 1, that is buzzer pin. Okay, so and this is happening continuously because this we have enclosed in while loop. So whatever statements are there in this while loop, that will get continuously executed. Okay, so depending on D sensor, if it is 1, it will generate square wave on buzzer pin, that is pin number 7 of 1, to which buzzer is connected, and it will generate sound. Otherwise it will not generate square wave. If D sensor is equal to 0 means that door is closed, then it will not generate square wave. Okay, so last part of this program is that is a ms delay function definition that we already discussed. Now we will compile this or build this program first to check for errors. So there are no errors. Now I will go in debug session. Okay, and now we have to use only port 1. Okay, now here I can observe output on port pin 7 of port 1 to which buzzer is connected. Okay, so here for that I will use logic analyzer. So there is a symbol, this you can click on this, it will open logic analyzer, means I can check logic on any port pin here. Okay, so for that I have to click on setup, and here I have to add the pin name. Okay, so here buzzer is the pin name I have declared, and this buzzer is analog, it is a bit. Okay, and okay, color is red, and it will display here. See here, buzzer. Now this window will display what is the logic on this buzzer pin, which is nothing but pin number 7 of port 1, to which a buzzer is connected. Okay, so on this pin there will be square wave when door is open. That is, if this condition is true, this sensor is equal to 1, then there will be square wave, okay, on this pin, and that will be supplied to buzzer, and buzzer will generate sound. Okay, if this D sensor is not equal to 1, means it is 0, here square wave will not generate. So we will monitor this pin here. Okay, so I will run the program and I will show you right now. Here that is we have connected door sensor to pin number 1 of port 1, that is D sensor, which is nothing but this pin. Right now this pin is 1. Okay, by default it is 1. Okay, because data in port 1 is ff, it is 1, means it should generate a square wave right now. Okay, on buzzer pin. If I run this program now, I will run this program. Okay, okay, it is generating square wave. Now I will change the data on pin number 1 of port 1. See, now square wave is not generating. Okay, on buzzer pin. Okay, so here again, if I make door sensor 1 D sensor, that is pin number 1 of port 1, again it will start generating square wave. Okay, so you can zoom in so that you can observe this square wave. Okay, or you can zoom out so that you can see. Okay, again if I change, see here, square wave is not generating on buzzer pin. In this way you can observe logic of a particular pin, okay, by using this logic analyzer tool that is readily available in this till compiler. Okay, in this way this program is monitoring this pin number 1 of port 1 to which door sensor is connected, and if door is open, means door sensor condition is 1. If 1 is being inputted to this pin, okay, then it will generate square wave. If it is 0, it will stop generating square wave, means it will stop the buzzer. Okay, if it is 1, buzzer will turn on. If it is 0, buzzer will turn off. Okay, in this way we can generate uh, a square wave on buzzer pin to sound the buzzer if door sensor is open. Okay, in this way uh, the program works. Okay, so this is the third program. Okay, so this is about practical number 2. Okay, that is a study of arithmetic operations and time delay, generating time delay. We can make use of these arithmetic operators and uh, time delay function, okay, to achieve such tasks. Okay, so here we completed practical number 2. Okay, any doubts you can ask on our WhatsApp group. Okay, so I think these three programs are sufficient. Now you can proceed writing a second practical write up. Okay, according to the format I have sent you. But in that write up, okay, you replace 3 programs. There are actually 4 programs. You replace probably 3. Okay, so you replace these programs by these programs. Okay, don't write whatever programs are there in the write up I have sent you for practical number 2. Okay, so what I can do, I can send you these programs, okay, in PDF. Okay, so that will be easy for you for writing the programs. Okay, so we will stop here. Any doubt you can contact me on WhatsApp in your group only. Okay, don't send me personal WhatsApp messages. Okay, so send me message on your group we have formed. Okay, so okay, I will stop here.